Today we're talking about volumes of pyramids and cones, and from the past you know that in a cylinder such as the one here, the volume can be calculated by taking the red section, which is the area of the base, and multiplying by the height of the object. Alright, so the red is the area of the base and the height of the object is as so. And a prism we know has two bases which are parallel to one another and separated by a height of h. So the volume, as I said, of a prism, in this case a square prism, because these lengths are equal, is area of the base times the height. Similarly for a cylinder, which we have below, once again the area of the base multiplied by the height gives us the volume of the cylinder. Since the area of the base is a circle, we can write pi r squared, which is the area of a circle, multiplied by h. So that's knowledge that you have from previous lessons or years. Now what we want to talk about is what is the connection with a pyramid and a prism. So you'll notice that I have a prism over here on the left, which has, or I have tried to draw it so that the base is exactly the same, and the height, which is the 90-degree distance from the base, is the same as the corresponding prism. So I have my pyramid here, and in classes you would have talked about the relationship and perhaps shown this in a number of ways. If you were to fill the pyramid with water and pour it into the prism, you would find that the relationship between the two is that the volume of the pyramid is a third the volume of the prism. In other words, it would take 3 of these to fill one of those. Again, assuming that the base and the height are the same. And similarly with a cone, as long as the base is the same and the height is the same as it is for the cylinder, it would take 3 of these to fill one of those. So the relationship that we have for the volume between a pyramid and a cone versus a prism and a cylinder is that the volume of a cone slash pyramid is 1/3 the volume of a cylinder or prism. And since the volume of a cylinder and a prism is area of the base times the height, the volume of a cone or a pyramid is 1/3 the area of the base times the height. Okay, let's take a look at 2 examples. So the first example, we have the volume of a cone. We want to find the volume of a cone with a height of 8 and a slant height of 11. Alright, so I'm going to draw my cone. Slant height, this distance here would be 11, because remember my height, which is always the vertical height, is at 90 degrees to the base. This is what we don't know in this case. And we have a radius, we have a height of 8. So to do the volume of a cone, we know that's 1/3 the area of the base times the height, which is 1/3 pi r squared, because the base is a circle, times the height to give us the volume. Alright, well if we take stock of what we have the height, h, as 8. We need the radius. We don't have that, but we notice that we can find that because if we narrow in on this triangle, we can calculate here the radius. So the radius squared, I'm using Pythagoras' theorem here, plus 8 squared would equal 11 squared. And if I manipulate the formula, subtract 64 on both sides, I'm going to get 57, and then square root that is the square root of 57. So I can bring that back up here. I can then put it all together with my formula, 1/3 pi radius squared times 8. Okay, before we resort to the calculator, let's just make that 7 a little bit clearer. Before we resort to the calculator, let's just simplify this expression. This is 1/3 pi times 57 times 8. 57 times 8 divided by 3. Let's bring up my calculator. 57 times 8 divided by 3 gives me 152. So that's 152 pi. And then if I type that into the calculator, I will find that 152 multiplied by pi will give me approximately 477.52. And centimeters cubed because we're doing volume. Okay, our next example, we want to find the side length of a right square pyramid with a height of 12 and a volume of 984 cubic centimeters. So let me just do a sketch of what this might look like. We have a square base. We don't know the side length here, so I'm going to call that S. And we have a height coming up from the middle of 12. And then our pyramid would look something like so. Okay, so let's make that's 12. Alright, so let's bring up, we're dealing with volume here, so we can say the volume of a pyramid we know is 1/3 the area of the base times the height. Let's fill into the formula what we know. We know that the volume is 984 equals 1/3. The area of the base we don't know, but we know we could calculate the area of the base as side squared, this area. So the area of the base is side squared, and the height we're told is 12. So 1/3 of 12 is 4. And we need to divide both sides by 4. And so the slant height would be the square root of 246, which means that approximately the slant height (15.68 centimeters).